Yesterday we learned about object-oriented programming. So just think that we're trying to sorry, we're trying to translate our thought models into the programmatic world. So that's the basic idea of object-oriented programming, because we humans are like we recognize the objects and then we try to operate on top of that, like drink water, store water, and things like that. So we are used to it. And remember that the classes and objects are uh, just like blueprint versus the actual object. So that's about like classes and objects. And then when you sort of read the code, do not get overwhelmed by looking at like large piece of code, right? For example, I'll show you here. So if you look at this, you suddenly feel like, okay, this is too much for me to consume. So what you generally do is, yesterday I was giving an analogy saying that it's like reading newspaper. Read the headlines. For example, in your ID, there are like this foldable uh, icons. So if you click that, it will just wrap up, and you can see the headlines like, okay, this is animal, and there is a dog which is inheriting class animal, and there is a cat and it's inheriting animal. So you make a mental model saying that, okay, there is animal and then there are like inherited items. So that is how you read, and then when you want to look at its functions, open one of them and then see what's happening. So we have function called as speak here, and we have function called as speak here, and we have another function called as init here, which initializes, which is called as constructor, but it's not a true constructor. True construction means there are two things happening. One is you ask for memory, which is there is a function called as new double underscore, which does that, and init initializes it. So together it's called as uh, construction. So that's why those functions are called as constructors. So in Python, in for general or the beginner level, init is the one which constructs, and we just remember that it's a constructor for now, but actual construction happens even before that. And then we also looked at so if you create an empty class, so Python will give you a lot of inbuilt code. For example, just to revise test class, and then here. So this is an empty class. So now I'm just running it. So since we are not printing anything, it is not showing anything. Let us try to print the in see the attributes and the functions which for which we use dir. Dir is like directory. You can simply say test, and look at this. You can see that there are, even for an empty class, there are several inbuilt functions that Python has provided. So these are like um, functions which are already defined in somewhere. So just remember that it's empty class means there is something inside that. Just like in C++, it provides some 5 things like constructor, destructor, copy operator, or some things, operator, something assignment operator, and there are several things. Similarly, Python also gives this sort of inbuilt functions. Okay. So okay. So that is how we like decode the code, which is slightly bigger for so this is smaller, but if it goes like 100 lines, just remember that do not get afraid. Just look at the headlines and then okay. And then we looked at encapsulation. Encapsulation has just remember 2 things, and forget about protected. So there are 3 items in 3 kinds of variables in terms of um, its accessibility. One is private, protected, and public. So in Python, just remember that we have only private and public. And in order to use protected, so there is the reason that we do not have protected properly in Python is because this is runtime, all the variables get identified during the runtime. So in order to get to know the protected variables, you need to like compile, pre-compile, and so that is difficult to implement, and it is also not required for people like who are not very academically trained in programming. So you don't require that. So just remember private and public variables in Python. Okay, so yesterday we saw double underscore means it's a private variable. Any variable which starts with double underscore is a private attribute. And we looked at, we also tried to simulate access this particular variable, and we got an error saying this particular variable is not accessible. So that is the basic idea of private variables. So where you can modify this is only inside the functions which are inside the class. So okay, yeah, and then we looked at polymorphism. It's slightly different from C++ and Java. So just remember that there is a you can call the functions of different objects which has same function, and then you can at the caller level you don't need to know the type of the object. So in runtime, Python resolves comes to know which type of um, object it is, and then it calls the respective functions. So that's about it. So yesterday we did all this, and this is the revision. And today we'll look at two concepts. So one is quite simple concept. It's called user input. So user input is like I'll I'll tell you the history of user input. So when you open a shell here, like Bash or ZSH in Mac, any shell, like go to the go to start and then open CMD in Windows. Similarly, in uh, Linux, you can open a terminal, and here you can open a terminal. You can go here and open a terminal here, new terminal. So when you open the terminal, what happens is I'll just give you a brief of Linux so that you know what is happening inside. Okay. So once you open the terminal, so we looked at in the first class, you remember we studied about operating system, and operating on top of operating systems, all these processes are running. So P1, P2, like that. So even this editor is a process, right? So this is getting executed constantly, and depending on the capability of the chip, so it is switching the context, and we don't come to know because now the chips are very powerful. If you remember in late 90s and early 2000s, where we had this PCs accessible to us in schools, so if you open multiple browsers or multiple windows, you'll get sort of stuck. Your mouse pointer won't move, and the computer will start making noises and things like that. So that is because the CPU gets a lot of uh, jobs to do, and context switching becomes difficult for CPU. Nowadays, we have a lot of RAM and CPU, and then we have a lot of resources at lower prices. That is why the computer manufacturers have now I think minimum is 8 GB RAM, and i5 and things like that. So yeah, that is how these things are related: process and operating system, and then the chips. And now coming back to the shell. So when there needs you cannot directly operate on operating system, right? You do not have any access here. So what operating systems do is they create something called as user space, or and there is a layer where users can access the um, functionalities of operating system. For example, listing a file. So you run a command like ls, and it lists all the files, right? So how does that ls gets run is user needs to have a gateway or path to run this command, right? So either you can go on UI and double click on say browser, which opens the browser, or there is command line way, where you do not have, so most of the systems which we, like embedded systems in production or during your testing, right? You do not have UI. UI is like extra layer added to all of this. So that's heavy operation. So we do not use UI. So most of the people you use command line. So once you open the command line, what happens is operating system spawns something called as shell. So these shells have capabilities. So what the shell does is, there is pencil. Where did it go? Is it- Here it is. Okay. Once we have shell opened, it gives us access to functionalities of like underlying operating system, which is in Python, sorry, in Linux world, it's called as kernel. So you can issue sort of commands to kernel. So kernel is the one which takes the input, like, okay, I need to open the process and then process it, and then schedule it and things like that. So that is taken care by kernel. So when you open the shell, so it opens a gateway and it takes in text. Okay. Text is nothing but now any text, but some texts are special, which is like commands. So it doesn't know whether this particular text is a command or not. So what it does is it starts reading from the line number one. If you have any text or simply stream of bytes. So if you give input as file, it will start reading from line number one. If you do not have any file given to it, if that command doesn't support any file, you'll just it will start processing from the first byte. So if it sees, what it does is it just picks that up and loads it onto the kernel. So he recognizes that, okay, this is a command based on there are formats for executables. So when you on the Windows or any machine, so if you click on a file, how does operating system know that it should open this, or it should open this in notepad and things like that. So there is something called as every file has got a header. So that header will decide, okay, whether it's an executable or not. Okay. So but okay, that's a different concept, so you can study further if you want. So but the shell is the one which picks up this command and starts executing it. So here we have opened one shell, and what if I want to give some inputs to this particular program? So you have created your own program, say Python some 01 dot py. I want, when I run this, I want this particular shell to wait for me and then take some input. So how do I make this particular kernel or operating system, to speak in general? So how do I make this process to stop and wait for the input? So that is what we're trying to do. So internally, what happens is there is something called as wait inside the um, inside the operating system. So it puts the process into that state, and it waits for a interrupt. So if you have studied in electronics in your beginning of your engineering, or even if you haven't, so there is something called as interrupt. So every key that we press and every mouse movement that we do, it is an interrupt for operating system. So it looks for that interrupt and it acts on that. So that action is decided by the programs. For example, somebody has programmed this mouse software and then tell that, okay, if this sensor gives me these values, move here and there and put the icon here and there based on the monitor resolution. So similarly, we have this waiting. Yeah, it's the same thing. So that particular device is waiting for an interrupt. So let us look at how that looks like. Okay, so let me remove this and clear all the drawings. So in general, uh, what happens is, let me create a new file. Py. So there is a function called as input. So all this happens here in just one function, whatever we spoke. So I will just declare some variable, and if I find this, my var is equal to say 0, I'll just define this variable, and so you can see that I ran and it is waiting for input. So if I give 3, it exits. So it takes an interrupt from, which is from the keyboard, and then when does it exit is when we press the enter. So enter is a character in Python or in operating system. So it is /n, which is called as new line. So that is why when we try to parse the file in the previous class, so when we try to read, uh, use read line, open the file and read line. So we looked at when we used read line, so it gave a list which is line by line, and every line ended with /n, \n. So that is when it knows that, okay, I need to get out of this interrupt or get out of this waiting state. Okay, so this is the input function which is inbuilt and does whatever we spoke. So it is very easy to like in a way tell you that, okay, use input to wait for input. But you don't have to remember this function. Like, you need to remember what happens internally. So there is a shell, there is an operating system, there is a uh, hardware below that. So hardware, we are orchestrating through operating system. Operating system again has some options to control these interrupts, wait for these interrupts, and then we are trying to handle that. So this input is the one which waits for the user input. So this is a very simple solution for to make something work. Like, you take an input and do some processing. So let us take say name. Okay, so let me print. We don't have any prints, that is why it's not printing anything. So let me run this. So it takes and you can see that I typed in Digant, and then once I pressed enter, there is a character which is not visible, which is nothing but /n. So then it knows that, okay, I need to get out of the program. So, and then you know that, okay, we are just printing it. We are storing it in a variable, because the reason that we are taking input is we need to do something, and in order to do something, you need to store that value. So now let me try to enter some number, and I'll show you some error. I'll take x is equal to input, and um, I'll just put I is equal to 0, and then I'll copy paste it again, and I'll change the variable names so that I can have two inputs. And let me try to um, add x and y. So this is to you know show you how clear this. So what is the problem with the input and what not the problem, the feature of the input. So let me try to run this. Let me save this, and so it's waiting for somebody to input. So let me type say 8, and then let me say 10. Now it says okay, 8 and 10. Where is it? Okay. You can see that we try to sum up 8 and 10, and you can see that output is 8, 10. And let us understand why it is. It's not 8 plus 10, right? It's not 18. Why is 8, 10? So that is because the so uh, when you see problems like this, so you know there are two functions which are like, one is dir, another is id, another is uh, yeah, dir and type. So these two functions, just remember that it's very helpful to understand what's happening. So let us look at the type of x. So let me run it again, and now let me, you can see that this input, whatever we have taken, is of type string in line number 5. We are printing it, and this. So that is the reason it is not adding, because for human eyes, it looks like it's an integer addition. When we say add something, so we naturally add, but we are not used to like string concatenation by default, right? Humans. So, but the computer programs look at this in totally different way. We need to tell that what sort of addition it is, like that. So because if this number x was an integer type, it will do the integer addition. If it is a string type addition, it will do the string type of addition, which is concatenation. So let us try to give two different types of input. For example, I will do hi. This is a string, and I'll give you. So I'll provide 2 as an input. So you look at this; it comes as hi 2 because 2 is taken as a string. So in this case, how do I anything that we input is will become a string for input. So how do you come to know that? Is just hover on input if you are on ID, or you can also do if you have an have internet connection, look at its definition. What is the input and what is the output? And you can see that standard, it is printed standard output trailing new line, and trailing new line is stripped. So read the string from standard input, and then yeah, if it's so that is how you sort of read the documents. So this particular document is coming from something we, I think we didn't cover, but there is something called as doc strings in functions. I'll just show you what are doc strings. So how do I convert this into integers is simply like this. I can convert from one type to another type using this. So just like in C++ and Java, similarly, we have, like, you can convert the types. So let me put 2, and then let me put 3. Now you know that it's a string here, but I have converted to integer. That is why we are getting 2 plus 3, which is uh, correct, 5. Okay, this is how the type conversion is done using input. So, for example, why do we need such things? Input is probably you are writing a script in automation. Say you want to take an IP address and ping that particular IP address, whether it is there in the network, and probably return something and then do some processing. Again, you need to take some more input, say subnet, excuse me, submit, and then sort of validate it and then proceed and things like that. So there are, you might have um come across such programs already. So in order to write such programs, this is one of the ways to do it. So this is about input. So yeah, it's a fairly simple concept. Yeah, you can uh, try it. So then what happens if I do not convert? So so this is nothing related to input, but let me just demonstrate what I mean. Now I gave two inputs, which is 3 and 4. So both of them are strings here. And then I'm trying to add an integer. I have converted string to an integer. And then I'm trying to add string as this. I have not converted y to string. So when we try to add integer and string, we get some sort of error, which is type error. Okay. And you can see here in the traceback. This is the traceback. I'll come to traceback in a minute, which is another concept we are going to study today. And then we have file, and then we have print, and so on. So it says that unsupported operating types something something int and string. So at CPU level, it's just stream of bytes. It doesn't matter what sort of types it is. So it is getting. So it will just do the addition. So at the bitwise level, but we need to have some sort of control at at a runtime environment in Python or in C++. It's compile time environment. We should make sure that two different types of data types should not be mixed unless intended. So of course there is no operation where you sort of add a number and a string. It doesn't make sense, right? So similarly, it's like if somebody says what is the sum of say two apples and then one pen, right? You can count the number of items, but it's not correct. So that is the reason that somebody has programmed saying that this is an unsupported operand. So any questions in input type conversion, and then uh, uh, no this error. Okay, I hope that is clear. So let me just so remember this output. Let me just write say two functions, which is like def and one and print. Okay. And let me write another function, which is function two. And then I'll have two functions. And let me write um, say another function, which is say, let me call this as main function. But there is no main function in Python. This is just a like this can be anything. Main. So I have three functions. Let me call inside main. I'll just call say function one and function two. So if I run this, nothing will happen because there is no calling of that particular function main. So I'll just call this main function, and as expected, it goes through line number 9. It prints in main, which is here, and prints something which it calls the function one, and it calls function two, which we are printing hi hello. Now we have this function calling sequence. So what might happen is, so we have already seen this. Let me demonstrate something here. So print one plus um, e. Okay. So let me just try to call this. So let us try to understand what's happening here. So function 2 has print hello. I'll just fold this so that we can take a look at this. Let me annotate so that I can draw on. So we have main function. Within the main function, the control flow is like function 1 and function 2. So this function, has it got executed? Let us look at that. So how do we come to know? So I have executed here. So via this triangle button. And then if you look at this type error, let us try to analyze this type error. This is interesting. Why does this particular block come into picture? And what does this mean in terms of uh, programming? And then how do we relate, or how does it help us to solve the problem? So if you look at this particular block, the red ones, it's called as traceback. So let me tell you something about how the programmers, how the programs work and internally, little, in a very brief way. So when you write a program, so all these variables, so there are variables in program, and then there are different types of variables, and there are functions, and there is somebody who is calling it, say a main function. So even if you are working on a chip, say 8086 or any chip, so you'll have some instruction which gets translated to opcode, which is a machine level, it gets translated to bits finally. So this main function will have maybe gets translated to something called as, say, begin in assembly level language, and probably some opcode. So let us just say 00 some bytes for CPU to know that, okay, this is the starting of the program. So when I write this, so it starts from there and it keeps on working on the next instruction. So how does it get the next instruction? Is via something called as instruction pointer, or it's also called as like program counter or something like that. Instruction, let us just say instruction pointer. So it always points to, it executes and it points to the next one, the next set of instruction. And when we write functions, so when we execute the program, so program has something called as stacks. So program, the structure of the program. So the operating system needs to feed this data, program data, into the RAM, and then CPU reads. CPU doesn't know there are like stacks, and there is heap, there is the RAM and all these things. So it just points to next address of the at the in the RAM. So it looks at, it just has one like placeholder. It will just pick up the instruction from that particular piece of RAM. So we have got structure of a program, which is like, we define the structure of this program, which is nothing but a process. The process will contain these sections. One is the stack, another is called as heap, and there are few other sections. Let us just call this as like uh, where global variables are kept, and some other additional things like BSS, and there are other things. So let us just focus on stack and heap. So what happens when we call a function is this particular block, say when we call this main function, it gets loaded onto the stack. So the stack and heap are just like sections of the program which are now on the uh, memory. So you load the main onto the stack. It's like, you can imagine you are having a deck of cards, which is like, you put that on vertically like this, and then when you have main function, so this is the operating system which is trying to execute that particular section of the program. So it loads this main, And once main is completed, it removes that from the memory. So now I have two functions, like function one and function two. So it looks at function one and function two from the code section. It looks okay, function one is coming. So it puts main. Now I got the main. And then within main in line number 11, we have function one. It puts the function one. So now we have two things in the stack. One is main and one is function one. And it executes function one, and function one will go uh, uh, out of the stack. So we remove this and then we put the function two. Now we have main and then there is function two. So if we have called function two here, now we will have like main function one and then function two. Okay, but here we have main function one is done, and we remove that card, and then function two is loaded. So that is the use of the stack. So why this is done is because we need to know the scope of variables, and then we need to sort of play around with the variables. So all the variables go out of the scope. This is the reason that scoping is present in all the languages, because we are trying to play around with the memory. So I hope we understood why there is a stack and what is a heap. Heap is nothing but when we allocate any memory. Like for example, you may be creating say dictionary inside this function, maybe creating say list, maybe writing a for loop with range. So we sort of allocate memory on the RAM and store the addresses. So stack is like one top of one another. So heap is like it's in your RAM. There is like we saw that it's just a row of houses, and heap can have uh, can store the addresses of this memory, starting addresses of a memory, and then it knows that okay, I have this much of memory now. Say it has got hold of two addresses, and each of the addresses start with some x and then end with y, and that particular memory block, the sum of all the houses or sum of all the blocks, is what is heap. So that is called as heap memory. So this is nothing but the RAM memory, which is not in sequential order. That's it. So heap is RAM, which is not in a sequential order. So it's like we need to delete that particular memory that we have already taken. So how do we delete? Is in Python, garbage collection does that job, but in C++, you need to actually use free, or you need to like malloc and then free, right? So it's similarly in C. I think there is something else, like you can do it in the destructor, and similar to new and I think delete. So when you do the new, you are allocating memory on the heap. When you are deleting, you are taking it out. But in Python and Java, there is something called as garbage collection, which does once the variable gets out of the context, it automatically removes. There is a process which removes the memory, allocated memory. So this is the underlying concept of how this function call gets called. Okay, so this is the mental model that you need to have. So if you learn any language, so now you'll have that model. Okay, there is stack, there is heap, and there is instruction pointer at CPU, and then somebody begins that program, and this is how it sequentially works. You take any program, there will be a beginning instruction. In Python, it is just the line number one, because it reads from the line number one. In C++ and C, there is a function called as void main. Even in Java, there is a main function. So that is where the program execution begins. Okay. So now why do we need all these things in mind to understand this? Is you can see this lines here on this section, traceback section here. You can see that there is line number 14, which is here, and then there is line number 11. Let us look at this. So we got an error, which we simulated earlier. So I'm trying to add a number to a string, which is an error. So it stopped there. It sort of like vomited whatever the variables it had in its mind. So what has it, you know, thrown here. So this is called as throwing. So why it is called as throwing is like, it's like, okay, I have got something unexpected. Just I'm not executing this anymore. So I'm stopping it here, and then it's like throwing away whatever it has. So this has at line number 11 we have function 1 here, and line number 14 we have function main, and line number 3 we have function 1. Okay. And it says in line number 3, in this function, this particular print is the last instruction that I have executed. So what does it mean is simply saying that this particular error has occurred here, and this is the history of the calling. So that is where our stacks came into picture. So I called first function, which is main, and the next function was function 1, and next instruction or next thing that I faced is this particular line number 3, and this is what is happening, and I'm just throwing up an error. So why is this in this particular sequence is because we looked at like how does the stack gets loaded. So first thing we put main, second thing we put function 1. Now it is on the top of the stack, which is getting executed, current execution. And then I found something on function 1. So I'm going to throw the first element, or the first, I'm popping up element from the stack, and I'm just throwing it on you. And then again, uh, I'm going to empty all the things from the stack. So this is main, and I'm throwing it as well. So, and then it stops. So since it throws out all these frames of stack, it is called frame. Each one of the elements in the stack is called frame. And then all the frames are thrown. So now we know that in an order. So now we know that what is the order of the function call and why it happened. So this helps a lot when you try to debug. This is just like 10 lines of code, and there are new lines, but this is just a simple program. But imagine you have like tens of files and hundreds of lines of code, and then the program control is like you cannot list all the program control lines in your head, because it's difficult to remember, right? So when it errors out, we need a way to know that, okay, what was its path? So this is the path, and the path comes from the stacks. So that stack unwinding, so it is also called stack unwinding in some languages. So the output of the stack unwinding is called as trace back, because we are trying to trace back. So that is the underlying concept of this particular block, trace block. So this is a stack. We have unwinded the stack. These are the frames. So you can observe that we haven't executed this function too, because there is an error here, and then I just stopped at this error. I do not know how to handle it, so I'm just throwing all the stacks. Now I'm not executing this. Okay. So this is called as an exception in programming languages. So that is how we arrived at exceptions. So any doubts here, like in terms of concepts or anything?
Is there a scenario where like two concurrent functions or the operations getting executed at the same time?
Yeah. So generally, when you write a program in one go without using uh, intentionally using multiprocessing or multi-threading, which comes under concurrency, there is no way that you can create a parallel operation. So if you use certain libraries, or if you write some code to simulate this multiprocessing or multi-threading, so there is no way that program will split itself and start running on different cores. So it never happens. So when we run a program, it's always a single threaded program. So there is no such way.
Thank you.
But when you have multi-thread, what happens is, say there is a different process here, P1 and P2. Actually, it's a good question. So when this fails, like it throws up, it dumps its own stack, and process 2 has its own stack. So if it has some error, it will throw on its own way. Okay. So this is something that we did on terminal, which is like we logged into terminal and we tried to execute in the program. Like, so we are spawning a shell and we are trying to execute a program. But there, when you deploy a product in production, what happens is you just give a configuration file and say that execute this configuration file, and then the shell spawn by itself and execute and get out of it. So in Linux, if you want to run a process in the background and without hanging up, you use no hub command and it runs in the background, right? Similarly, there's a lot of processes are running in the background. So yeah, so each of the processes has, coming back to your question, its own stack and its own heap and its own instructions, everything. So this program structure is different for this program and this program. So that is the underlying concept. Okay. Any other questions? Okay. So now we have learned uh, how does the program actually takes into account of handling the throwing up the error that we have got. This is called as an exception. Okay. So now how do we now I you see that the function 2 is not executed at all, right? So how do I make sure that there can be several cases where I face a problem, but okay, but I also need to run this function too. So now I have just not executed function too. So how do I handle it in such a way that it it does not stop the execution of program and then just move on to the next set of instructions. So this is called as exception handling. So now we have got an exception, which is a trace back. So it is also the terminology comes from some stack trace. So stack trace is the one which we use in C++ and uh, uh, C terminologies. So because it's a stack and it is sort of throwing up. So trace back is similar thing. So this is a stack. So remember that these are frames in this stack, just like in deck of cards. So this we haven't executed this. How do we handle this properly? So that is where the exception handling comes into picture. Let me show you the now. Let me show you the how we do that in the code. Okay. So there is something called as try and in C++ it's try and catch. So in Python it is like this. So you identify the blocks of the code which can cause problems. So this comes at like at a implementation level or at the design level. So we say that this is a problematic code which we have now, and I'm going to put this in a like in such a way that I have a leash on that. I have some sort of control on that. Okay. Except, and I can write some. Okay, take some except. Now let us look at execution. Now you can see that function 2 got executed. Function 2 has hello. This part of the code, we have put it in such a way that it's like cushioned, like it's adding cushion, like it's like just like um, airbag in the car. Like you hit some block and then airbag opens and then you are sort of safe. So your next set of actions is not uh, affected. So maybe you wanted to go to a temple or something like that. So you can do the further processing. But if this happens, it's like death. Like uh, the function or the program just stops executing. So this you can think sort of an cushion, okay, or airbag. So this is how I have handled. So this is a generic way of handling the problem. Okay. So generally we don't not use prints in a production code. We use something called as logging. We will learn it soon. So we analyze the log, and then if we look for specific types of errors, and then look at what's happening and then debug that. Okay. So try and accept is the one which helps us to do that. So this is a general way of handling, and let us look at more functionalities in exceptions. Okay. So there are like hundreds of exceptions in Python. Like one, we have a value error, and then we have let me show you the list of errors. Python um, exceptions list. This here. Where did it go here? Okay. So if you just Google, I minimized it. Right. So you can see there are like several exceptions. Okay. So there are too many. Okay. So syntax error, indentation error, name error. We have seen some of them already. Value error, the one which we got. Type error, index error. Index error is the one which we get when we try to access index which is not present in the list. For example, if there is length of 4 sized list and we are trying to access the fifth one, it says index error. And key error is coming from the dictionary. We have seen that like there is no key in the dictionary, and then we are trying to access it, throws an key error. Zero division error, we try to attribute error and things like so you'll get used to this as you program, but that's the list. Probably if you define yourself, you can make hundreds of this one. So these are the basic ones that you have got, like more, not probably hundreds, but probably tens of them. Okay, let us try to understand the exception handling a little bit deeper. Okay, but that's the core concept of exception. Okay. So I'll send you this. This is the basic syntax that we saw. Try and accept, which I just demonstrated. Try and accept. Okay, and then you can also handle specific types of errors. So what if these functions or the functions above which um, we are calling, it can have several different sorts of errors. So how do you, if I put it in except, everything gets collected there. Like any problem, I'll just say that there was a problem. So for example, um, if it was say 1 divided by 0, so even if it is type error versus the uh, division by 0 error, I'll still print there was just a problem, but I do not know what exactly what exact problem was present. So for that purposes, we have specific exceptions. We can also say that try this particular cushion, which is like okay, try this. So if it is this, do something like this. We are trying to print, but you can also do a lot of other things. So you can have like list of exceptions, think that okay, it could be zero division error, value error, and you can keep on adding code like this. You can copy this and like have list of exceptions that you want to catch. And then so this is what we saw. Like there is an exception, zero division error, and yeah, and catching specific errors. Like yeah, you can have like lot of except instructions. You can catch value error, zero error, and so on. And there are the in this syntax as such, there are two optional blocks which is called as else, and there is also something called as finally. Else is something which gets executed when there is no problem, like there is no problem, this the code does not get hit, this particular code, and then you do this. Okay. For example, let me just run this. So it says, so this is not zero division error because we are dividing 10 by 2, which is perfectly fine. And if I do this, say, you see that I have handled the error saying that this and else block does not get executed. So when does this else block get executed is when you don't have any exceptions. Okay, so when do you use this is like there could be cases where there is no error, and then you do some normal operations after that. So that is where you use it else. And there is also there is something called as finally, which is a keyword used like this. You can have try, except, else, and finally. So these are optional ones, finally and else. So finally is like uh, whether there is an exception or not, it is as good as adding a code outside here. But to put it in one structure, we can use finally, saying that uh, finally you do this, whether there is an exception or not, just execute this code. So this is a good example where we open the file, and if that file is not present, for example, I have a file already called as example.txt here. You can see on the left side. So if that file is not there, it will say this particular error. So let me just, this particular file is not there. It says file is not found. So, and also it does this finally, executes this finally block. So in any case, you just um, do this. So this is actually used in cases where you want to release some of the resources. For example, here file is a resource and I'm releasing it here, like closing it. Closing it means that no more in use. So you can actually do it outside. Yes, you can do it outside, but some of the variables which we have defined it here may not be accessible here or may not be in current scope. It doesn't make sense to write it outside the finally outside this block of the code. So that is the difference between finally and just the code. And this is the syntax: try, except, else, and finally. So these are like uh, two things you need to remember: try and accept, and other two are optional. Else does if there is no exception. Else executes when there is no exception. Finally gets executed in any case. It's like finally you do this. Okay, so that's the exception handling in terms of Python. But the concept wise, so that is there is a stack and there is unwinding and there is all operating system, all these concepts comes into picture, right? So yeah, you can also yeah, you don't at the moment you don't you don't need to create your own custom exceptions, but you can create if you want. And also we can raise our own exceptions. You can have some part of code and based on condition, or you can just use rise keyword and then raise an exception. So whenever you raise an exception, we will get we will get stack unwinding automatically. For example, let me remove these two lines and put it back here. You can see that there is no inbuilt errors. For example, there is no divide by, let me make it say 2, and I'll send y as 2 so that it matches this condition. There is no inbuilt problem. So I'm not dividing it by 0, which is by default it gives some error. But here, if y is equal to 0, I can raise my own exception, which is done by using rise, and it does the same thing. It puts out the trace back, and then it does this. So in some editors, it also gives you code blocks like this, like 2 lines up and 2 lines or 1 line below, I think. Yeah. So this is a complete stack trace. Yeah, that's about uh, exceptions. And yeah, it's an interesting, and it is definitely required when you deal with bigger programs. Just remember that it's like a cushion or a airbag. Okay, we're past the time, but do you have any questions at this stage? Okay, then. Yeah. Yeah, just,
Um,
yeah, please ask. Yeah.
Digan, can we connect after the call just for 5 minutes if
Yeah, sure,
it's
sure. Yeah,
okay
yeah,
with you?
yeah,
Yeah.
yeah.